right, so we want to estimate this limit once again. This is the two-sided limit because we're not told about approaching from the left or approaching from the right. We're talking about the limit as x approaches 4 for 1 over x minus 4 squared. Now think about this for a second. Is this going to be, is this going to be continuous? Well, this sure does model to me. This looks a lot like that parent function we've seen before, 1 over x squared. And we know that that looks like this, where we have things going to a positive infinity. That doesn't sound very continuous in my mind. I also think, well, if I do plug in a 4, I have division by 0. So I know that 4 is actually not part of the domain for this function. So I'm expecting some weird stuff when I graph this. And yeah, that's what we expected. It was this shifted over to the right 4 units. Look, there it is. So let's think for a second about what this limit's going to be, because obviously that's what we're going for here. Well, as we approach positive 4 from the right, the values are getting higher and higher. Look at these outputs here. We're getting greater and greater outputs. As we approach positive 4 from the left, we're getting greater and greater outputs. So although there's an asymptote here, there's some crazy stuff happening in this function, even though it doesn't exist and it's not a removable discontinuity. Look at those outputs as we approach 4 from both sides. They are approaching the same thing. They're getting closer and closer to a positive infinity. So the limit as x approaches 4 for this function here is a positive infinity because both sides are approaching the same thing and both sides are approaching positive infinity. Here we have the limit as x approaches 0 for 1 over x. So once again, we've seen this function before, 1 over x. This is a parent function for us. We've dealt with this. We've seen this rational function before. So we want to know, what is the limit as x approaches 0? We're talking about two-sided limits, so we're thinking about both sides. As x approaches 0 from the left, look at those outputs. They're going down. They're going to a negative infinity as we get closer and closer to 0. As we get closer to 0 from the right, we're approaching a positive infinity. And so, if we look at our table, again, we're approaching positive infinity from the right. We're approaching negative infinity as we go to the left. That's approaching negative. That's approaching positive. They're approaching different values. And if we ever have something approaching different values from the left or the right, the limit does not exist. It doesn't exist.